Question 13 is the trig question. The photograph on the right shows a house. Part of the roof of this house is shown in the diagram below. AB is perpendicular to DC. Okay, so AB is perpendicular to DC, okay? And they kind of have to have something like that in there to tell you that it's right-angled triangles, okay? Because trig on junior cert is only with right-angled triangles. So that's normally why that line is in there. And you can also see the right-angled symbols. Those symbols mean right angles, okay? Or it could be an L as well. It could be, sorry, it could be an L like that. AD is 11.8 and DB is 2. The angle CAD is 20 and the angle DBC is X. And it's telling you here, note the angle ACB, so ACB, so that angle at the top is not a right angle, okay? And as a rule of thumb, you can never assume it's a right angle. The only time you can assume it, or the only time you can think it, is when it tells you or it has the right angle symbols in it. It says then use trig to work out the value of X. Give your answer correct to the nearest whole number. Okay, so now it refers to the photograph on the right. If you can't understand that photograph, that's okay, because they've kindly drawn the diagram here for you. Okay, so the roof of this house is, that's what's in our triangle down below. Okay, so we have to work out X. Okay, so we are trying to find this angle X over here. Okay, so if I'm to draw that triangle, okay, that has X in it, let's see if I can draw straight lines. That's my X degrees, that's my 2, and that's C, B, D. Okay, so look what I did. I literally isolated the triangle that X was in. Okay, so I can see what is going on in that triangle that has X, because that's what I was asked to work out. Okay, and I suppose I could put a H in there, that's a height H. Okay, now how do we do right angle trig? Okay, so I'm taking you to the log tables, to the trig section, okay? And the trig section in your log table is quite long, okay? It starts here on page 13, okay? But the page you need is page 16. And you'll see page 16 is broken up into 2 halves. You have right angled triangle down the bottom, and you have what I call the non-right angle up the top. Okay, you can see there's the right angle symbol, there's none of them in this triangle, so that's non-right angled trig. Okay, but on your course for junior cert is right angled trigonometry. Okay, so it's this box here that is literally your Bible for trig questions. So everything you need to answer a trig question is in this box. So the tools you have are sine, cos and tan, or Pythagoras Theorem. Okay, so firstly, if we look at Pythagoras Theorem, c squared is equal to a squared plus b squared. So what does that mean? Well, they've drawn this diagram of a triangle, okay, and they've labelled the sides small a, small b, small c, okay, and they've labelled the angle capital A. Now, what you need to see is that side A is opposite angle A, side C would be opposite angle C, and angle big B would be opposite side B. Okay, that's how they label the triangle, and you can see they've done that at the top for all of them. Okay, so that's how your log tables labels the sides and angles. The sides are small letters, the angles are big letters. Okay, so therefore when I look at Pythagoras' theorem and I see all small letters, then I think, well, Pythagoras' theorem is used then for finding the length of a side And to find the length of a side using Pythagoras' theorem, I need to know what the other two sides are. There are no angles in Pythagoras' theorem. Okay, so if I need to find an angle or I have information about an angle, I'm using either sine, cos, or tan. Okay, because you see that capital letter, that's sine of the angle A, cos of the angle A, tan of the angle A. And all these trig identities, as they're called, or ratios, what they do is they link sides together. So there's a relationship in a triangle between angles and sides. So it's saying if you get the sine of this angle A, okay, you'll find that it's actually equal to the length of A over the length of C. Or it's saying, okay, if you get cos of that angle A, okay, and cos is just a function. It's just you do something to the angle. So it's a bit like square it or square root it or any of those functions that we do to numbers. Sine, cos, tan are just more functions, okay? So if you get what's called the cos of that angle, you'll find that it will be exactly equal to whatever length B is over the length C. And in the same way, if you get the tan of that angle A, it would be equal to the length of that side A over B. So you can see each of them take two different sides. Okay, and that's about it. So how do I use that then to solve a trig question? Okay, well, the first thing you need to write down is that sine, cos, tan. Okay, and there's loads of different rhymes for it. I use an old one. It's called Silly Old Harry. So silly old Harry caught a herring. Yeah, I think that's how you spell it. Trawling off America. Okay, so what does that mean? Have I lost the run of myself? Well, no, it's the first letters that I'm going to take out of all of this. Okay, and I'm going to write down a rhyme. Sine of an angle is equal to an opposite side over the hypotenuse. I'm just taking all these first letters, okay? Cos is equal to an adjacent side over a hypotenuse. Tan is equal to an opposite side over an adjacent side. Okay, another rhyme I often use is, oh hell, another hour of algebra. Okay, and some people find this one easier to remember. And then you have to remember yourself the order sine, cos, tan, but it matches the order in the log tables, sine, cos, tan. So it doesn't matter how you remember these relationships between sine, cos, and tan and the sides. In other words, which pair of sides go with which one. You have to find a way to remember them, or a rhyme, and you've got to remember them. Okay, so when I'm talking about opposite, adjacent, and hypotenuse, what do I mean by that? Okay, well, you label the sides with respect to an angle. So in other words, see this angle X that's here, okay? So let me label the sides from this spot, okay? So the side opposite your angle, so you see the way I draw an arrow, so very opposite it is your opposite side. Okay, so that's your opposite. So this is the O that's in any of my rhymes. See the O? That's your opposite side. Now, there's a special name for the side that's opposite a right angle. It's always called the hypotenuse. Always called that. The side opposite the right angle. Okay? And then the side that's beside the angle is what we call your adjacent side. Okay? Adjacent. It's an English word and it just means beside or close to. So adjacent. So this here is your adjacent side, the side that measures 2. The side that's labelled H is opposite that angle X. The side that's opposite the right angle is called hypotenuse. Okay, let's do another example of that. Okay, so let's call this angle up here Y. Okay, and there's your right angle. And let's label our sides. So sine, cos, and tan. So oh hell, another hour of algebra. Okay, let's label our sides. The side opposite the right angle is your hypotenuse, often shortened to HYP, hypotenuse. Okay, the side opposite your angle, so you can see it's opposite the angle. So this is your opposite side, which means this one here beside it, or the other one left, is the adjacent side. Okay, so there's 2 very important things you need to do at the start of any question. You need to write down your trig ratios and you need to label your sides. Okay, so I hope that's clear. Okay, so I'm going to rub all out here now and I'm going to show you how I would answer this question. Okay, so just like I said, I would isolate the triangle that had X in it. So maybe I'll do it up here. Okay, so there's my X, there's my 2, there's my H. And I don't put anything else into it, just the relevant information. Okay, I write down my rhyme. Silly old Harry caught a herring trawling off America. So any corrector correcting your paper will look for this. Do you know your trig ratios and can you write them down? I then label my sides. So this is my hypotenuse. This one is opposite my angle. And this is my adjacent. Okay. So what you'll find is any of these will give you that angle X, okay? But it comes down to what information do you have in the triangle and which one do you have enough to use, okay? So I could write down, I could use sine of X, okay? So sine of the angle equals, it's telling me to use the opposite side over the hypotenuse. So my opposite is H. I'm going to put down opposite over hypotenuse first. So it's that side H over HYP. I don't know what it is. Okay, so I have 2 unknowns there. I have X, the angle, the hypotenuse. I have 3 unknowns and H. Okay, so you can only ever solve an equation when you just have 1 unknown. Okay, so I can't really use sine just yet to solve that. I have too many unknowns. Okay, let's try cos. And that's equal to adjacent over hypotenuse. My adjacent is 2 and my hypotenuse is HYP. Okay, so this one is a bit better, but I still have 2 unknowns. Look at that, okay? So I can't use that just yet. Let's try tan. Because like I said, any of these will give us the angle. They all give you the same answer. It just depends on, do you have enough information to use them? Okay, so tan is opposite over adjacent. Okay, my opposite is H, my adjacent is 2. Okay, So again, as it stands, I can't use the tan yet to find the angle x, okay? In all of these, I have two unknowns. So does that mean I can't answer the question? Well, no. So let's come back to our diagram, okay? Why did they give us so much information in this diagram and just ask us to find h? Well, the reason they did that was I must be able to find this value h, but using the other triangle. Okay, so let's go on to a new page and let's see if we can find that angle h, okay? So let me take a copy of this with me. Onto the new page. Okay, and let's find that angle h. Okay, so now my triangle of interest is not the little one with x in it just yet because I can't use it. Okay, so let's draw the other triangle. So this is A, C, and D. This is H. This is 11.8. This is 20 degrees, okay? I'm actually going to rub out, I think, the A, C, and H so that you don't get confused by them. Okay, and put in our right angle. Okay, so again, let's label our sides. So this is the angle that we know, so it's all with respect to that one. So there's my opposite side. If this one is my right angle, then this one is my hypotenuse. It's the side across from it. And then this one is the one beside my angle, so it must be my adjacent side. Let's write down my rhyme. Silly old Harry caught a herring trawling off America. Okay, so do I have to go down through them all like I did here to figure out which one is the right one to use? Well, you might have to for the first question or two until you see it, okay? But this is what you're looking for. You're asking yourself, what information do I have? So see the way I have my angle now, so that's good. I have information about adjacent, so he's good and he's good. I have information about him. And then you're going, what side do I want to work out? So I want to work out the opposite. So that's the one that I need, and that's the one that I need. Okay, so then you're looking for which one links what you need with what you have. So tan. Tan is the best one to use there. No point in using cos because it doesn't have opposite in it. So I'll never be able to work out side H, okay? So that's the first one to get rid of. That doesn't even have the opposite side in it, which is the O. So it's down to either sine or tan. This one is going opposite over hypotenuse. I don't know the hypotenuse, so he's not much good for this particular question. So the right one to use is tan. Okay, so what you say is tan of the angle, and I know what the angle is in this question. It's 20 degrees. So tan 20 is equal to opposite over adjacent. So tan 20 is equal to opposite, which is H, over adjacent, which is 11.8. Okay, I need to solve this then for H. So how do I get rid of 11.8 from this right-hand side? Okay, well, two ways. It's under the line here. So therefore, if you multiply by 11.8, so in other words, if it's on the top, what's going to happen is 11.8 on the top and 11.8 on the bottom will cancel. But what I do to one side, I have to do to the other. So therefore, you end up with 11.8 multiplied by tan 20 is equal to H. Okay, so just to repeat that, 11.8 was on the bottom on this side. So to cancel it, I need 11.8 on the top, and when it's on the top, it means multiply. So put it on the top there, put it on the top here. They'll cancel on this side, so you're left with just H on the right, which is what you want, because you want to solve for H, and you end up with 11.8 by tan 20. Get your calculator and just go 11.8, multiply by, hit the tan button, 20, close your bracket, and you get 4.2948 is equal to h. Okay, so now you know h. Okay, so I'll round that to 4.29 is equal to h. Okay, so 4.29 is the height of that h. Okay, so if I go back here now, I know here's it's not 98, 4.29. Okay, so now I know my h is 4.29. And I also know, where was the other h? Down here, 4.29. Okay, so now I don't have two unknowns here. Do you see that? I still have two unknowns here, so I don't use sine. I don't use tan because I still have two unknowns. Both of them are looking for hypotenuse and I don't have hypotenuse. Right, so that's what I'm going to do here. But I'm going to rub it out and I'm going to explain it all again. Okay, so now I know h. I figured out h. Okay, so it's 4.29. And I need this angle x. So again, silly old Harry caught a herring trawling off America. Okay, so you're asking yourself, what links the two sides that you know and the angle that you don't know? So what links adjacent and opposite together? So go down to them, opposite hypotenuse, no, adjacent hypotenuse, no, opposite and adjacent, it's a tan. So you can write down then the tan of the angle, and I don't know the angle in this one, it's 10, is equal to opposite over adjacent, or tan of that angle x is equal to, what's your opposite? It's that 4.29 over your adjacent side, which is 2. Okay, so tan x equals, so I'm hitting my fraction button and I'm just putting this into the calculator. So 4.29 over 2, 4.29 over 2, and it's equal to 2.145. Okay, now I don't want tan x, I want the angle x, okay? So I need to get rid of this tan. I just want x, the angle, equals something. So the opposite of tan, and why am I looking for the opposite? Well, if I gave you x squared is equal to 16, I'd ask you what cancels the square, and you would tell me square root, because square and square root cancel. Okay, in a similar fashion now, I'm asking you what cancels tan, okay, or what is the opposite of tan? Okay, and the opposite of tan sits behind it on the calculator. It's tan inverse, okay? What I do to one side, I have to do to the other. And what you'll find on the left is that tan and tan inverse cancel. So you're left with x, the angle, being equal to tan inverse of 2.145. So put that into the calculator. So hit shift and that tan button to get tan inverse 2.145. And I am getting x being equal to, it's 65.005 degrees, 65 degrees because it's at the nearest whole number. Okay, so that's equal to 65 degrees. So to summarize, x was what you needed, and it was in a triangle where you didn't have enough information. So to be able to get x, we had to first find h. To find h, we drew the right angle triangle that contained h. We labelled our sides. We wrote out our trig ratios. We figured out tan was the right one to use because it was opposite that we needed and adjacent, and the relationship between them is tan. And then we solved it for h. Once we had our h, we went back to the other triangle that contained x. because that also contains h. We filled in our 4.29. We figured out it was again tan that linked our angle with adjacent and opposite. This time we had to use tan inverse. You always have to use the inverse if it's an angle you need. And we figured out that angle was 65 degrees. Okay, so that was the trig question on that sample paper.